Hey guys, what's up? Eddie Aho here with KissAnalog.com and Zoe or Zotek in the lab. Okay, I have the new ZT703 scope meter here in the hand, and this one is the 702S. So 703S, the new one, 702S, the older one. What's the main difference? The main difference is now we get two channel. And if you notice that, it looks like they thought that out when they did the 702, the single channel, because they put it in the right spot so they could add a second channel. So guys, it looks like they knew they're going to do that with this package. They are in the same package. So let's talk about the similarities. They're both oscilloscopes and multimeters. They both have the same package, right? The red's the rubberized, nice grippy, and the gray is the harder plastic, ABS plastic, so it's very durable. That's a very durable plastic. They both have the same keypad, same 4 inlets down here, okay? Now, by the way, I'm going to take this thing off. See the sticker? They had it on the other one too. They're trying to remind people, hey, make sure when you're going to measure voltage, don't have your probe in the current probe setting because you're going to short that out, right? When you're measuring current, it's just a shunt, very small ohms, so it doesn't interfere with your circuit. When you go to voltage, you just shorted out your meter. So that's also a safety issue. It's not good for the meter, and even if the meter can protect you, it's going to blow a fuse at the very least. So all right, guys, we got that taken care of. Hey, you know what? By the way, I'm going to take this little film off the screen. Nice screens. All right, guys, I'm going to show you, I'm going to go through the menus. I'm just going to kind of show you the difference, okay? First of all, look at the old one, okay, the 702S. Hey, guys, just want to jump in real quick. This turned out to be a really long video, so just speed through it, jump through it if you don't want to watch it all. But I did it so that if you really are interested in one of these scopes, I tried to go in as much depth as I could. Now, these long videos are really tough editing. It takes me a long time to do. So, yeah, I'd rather do a nice, short, easy video. But so hopefully you like it and give me a thumbs up on the video for, effort, if nothing else. Let's jump into it. All right, let's just look at what you get. You get this little pouch, which is very roomy, big enough to put all your stuff in. Now, this plastic packet, you kind of have to roll over a little bit. It's 60 megahertz probe. This is great. That's when it's in times 10. Guys, most of the time your probe should be in times 10, okay? Times 1 limits any scope. The probes will go down about 1 meg, all right? So put them in times 10. Switchable times 10 times 1. So very nice. Just make sure they're already switched in times 10. All right, so then the bag, it's a nice, it's got a little bit of padding on both front and back. It's got a little handle and no pockets inside. You got your manual. They both have the same test leads, okay? And they're nice test leads. You can see how floppy they are. They're soft, but they're PVC, I suppose. But God, they kind of feel like silicone. I'm not really actually positive. Yeah, you know what? I'm not actually positive because they're so soft. But also the gray is kind of rubberized plastic. The red is hard plastic. And so they're comfortable. Nice, tension relief on the end of them. The plugs are on an angle, which are nice when you're plugging them into the unit. They kind of go on an angle away from your bench. So you don't have to, worry about popping over. And then the ZT702S single channel comes with a temperature probe. The 703S, the new one, does not have the temperature probe. 703 also comes with the single probe, which might be because these are early units. So I got to check on that, make sure they come with 2 probes since it's a 2-channel scope, right? So here we are. Let's go through the menus. Now, one thing, just to turn them on, you hold them down just for a moment and O2, hold it down for a little bit longer. Okay, when you turn them off, I just want to show you the difference while we're starting off. You see this shutdown sequence, a little bar. On this one, you just know you have to hold it. But I kind of like that they added that little bar saying, come on, hold down, we're almost there. But anyway, let's turn it back on. So the 703S does come on a little quicker, right? Now the screens are very nice. All right, so the IPS display, it's in plane switching is what that stands for, but it looks kind of like a OLED, right? You can see like at a 45-degree angle, the angles are very good, the color's very bright, so that's great. Not quite as good as an OLED, but then again, they don't have the burn-out problem or the burn-in problem as an OLED, so there's not an aging issue with this type of display. It's just another type of LCD display, which is really nice. So you can see the newer 703S is larger, right? So measurements wise, this is a 2.8 and this is a 3.5. So that's significant. If I noticed on the old one, you see the little kind of frame? It's like a frame that went all the way around it. And if you look at that, compared to this, it looks like that's where they put the large display. So it's almost like they framed it where they're going to cut it out, and then in the tooling they just cut that part out for the larger display. So it seems as if they had this plan from the beginning, which I'm not too surprised. Now again, the case is just a 2 versus the 1, and yeah, they both have the same port on the side, which, just to show you that again, the charging port there, the USB-C, and then the thing for the compensation. Okay, and also in the case of this one, 703, that's also your generator output. Okay, so keep those silicon doors closed when you're testing, higher voltages for safety's sake, just so you don't touch anything metal. Don't want to touch those if you're touching the displays. Now, just because this one is larger, look how much nicer it is to read and see things. They're able to put a little bit more information, on the displays. Like in this case, there's 2 channels, so they have to have channel 1, channel 2, but then they also show the signal generator, and it looks like it's on right now. So on this one, they show 3 measurements. There's 6 in total. I'll show you how to get the other 3. In this one, you turn the measurements on and you can get, I think there's 8 or 9 measurements on the new one. So that's pretty neat. Now also, this little window up here, this is the little part in the middle, that green with the brackets. That's the part you're seeing here on the screen, okay? And see right here? So this is 500 microseconds, 5 microseconds. So let me get the time the same. So I'm moving this. See how that's spreading open? Okay, there's 250 and then 5. So at 250, okay, about 100, we're about the same, about a third of that screen. So this one, I guess I have to point that out. The new one has a lot more memory. So this one goes up to 280 megasamples, where this one is 48 megasamples, okay? When you open this up, there's 250. We're pretty much fully open. And then 500, we're getting the full samples here. Now the difference, what that means is when you're something like this, you've got some pre-trigger out here that's actually captured, and some post-trigger, some things pre and post what's on the screen that you can scroll back and forth and look at. So you just get more data, like deeper memory with the newer one, okay? Okay, so volts and time. So I already showed you how to move time on this one. Same thing on this one. So 2 milliseconds, 10 milliseconds. So, oh, there we go. So once we get up real high, then it fully uses the whole screen, like 200 milliseconds. So anyway, so that's the time, and then up and down is the volts, okay? So channel 1 selected on this one, and this one, since there's no channel to select, it tells you up here where the volts are. This one's telling you milliseconds. They both have the time base here, but in this one it shows you a trigger and then the trigger volts, like what voltage the trigger's triggering on. And this one's also showing you the trigger volts, and but it doesn't show you, I'm looking for the rising edge. See, it doesn't show me that information here, right? But here I can see it's the rising edge. And also it says 1 because it's triggering on channel 1, and it's also color coded yellow for channel 1. They both have the run, so when you run or stop, see if I stop it, so, and I let it take off and run again, so you can see the information, battery information of course, And again, channel 1, volts per division, channel 2, volts per division, generator, and 3 of the measurements, frequency, voltage peak to peak, and voltage max. Okay, so that's the volts times, and then we have move. Okay, and then move, I think this is for the trigger. See the little arrows up here where the trigger is? So let's go ahead and move. Yep, see the green one? And you can also see in the top of the display, see how the trigger is in the middle of that display window? It's moving along with it. So, and then if I hit the menu button, it just pops it in the middle. On the move menu, I can move the trace up and down the screen, so I can place it where I want, okay? And for channel 2, I have to come over here, hit move again, and it goes to blue, okay? Then I can move the blue one up and down, all right? So only one channel here, so that's the difference there. Okay, trigger. Okay, now we can play around the trigger. I can move them up and down. And you can see the little green arrow on both sides. And it also shows you a line up. It lights up while I move it. And it looks like on the new one, it keeps it there because I didn't see it disappear like I did on the other one. Okay, so it's kind of common that a lot of scopes will just disappear. Now, yeah, so that's interesting. Now they're both kind of staying. Okay, it goes away. This one's still there. So interesting. Okay, and then the trigger across the top, I can move that. So, you know, see the 2 arrows? That's the trigger. I'm moving it again. Okay. And again, if I hold the menu down, it locks it in. Okay, it's kind of interesting. I don't see on this one that I can move the trigger back and forth. It's like I have to go to the move menu for that. So see, in the 702, that doesn't make a lot of sense. So it looks like they fixed that on this one. So a trigger, you can still move. I mean, you have the 4 buttons, so why not make it so you can do that? So it seems like this one's a little more polished, right? Okay, so then we have DC or AC coupling for the probe. So if I want to strip off the DC, let's say if I'm looking at 3.3 volt signal and I want to see the ripple on top, I could hit AC, so the 3.3 volts is filtered out with the capacitive coupling, and then I just end up with the ripple on top, and then I can use my volts per division to zoom in on that and take a close look, okay? So on this one, we go to cursors. Now, there's no cursors, right? Okay, so I got to show you that. It's kind of, this is one of those things I think I got to talk to him about, because I think when you do this, it should just turn them on. But here, I'll show you. We're going to go to another menu, okay? So we have, this is one window with 4 options, right? 1, 2, 3, 4. So there's one window. I'll show you well, here, let's just click them both, okay? See, now we got the AC coupling right here for the probe. Okay, so there's DC AC. Here's our mode of operation. We're in auto mode right now, so we're just auto triggering. And there's normal triggering and single triggering. Okay, so see, it says wait, I'm waiting for a trigger. Okay, auto, and then it's just running. And then normal is it's waiting, and it'll trigger, and then it'll trigger, and then it'll just keep triggering whenever something crosses the settings that we have for the trigger. But in single, it'll do it one time, and then auto, okay? So, you know what? Let me just go through one at a time, because they are in different orders, okay? I mean, they do have the Probe 10, the 1X, 10X, that works the same way. The coupling right here is over here, DC AC, where it's DC AC here. But the enable, okay, this turns on and off the channel, okay? So I'm on channel 1 right now. So if I click channel 2, make that active, I can turn off channel 2. Now if I go channel 1, try to turn it off, it says, no, you got to have at least one channel on. So it doesn't let me do that. So I go channel 2, turn it back on. Now this one doesn't have 2 channels, so there's no reason to have that. Okay, so on the 702, the older one, the single channel, when you do trigger, rising or falling, I don't really see an indication on the screen. So you just have to kind of know which one you're in, I think. If I turn off the menu, yeah, so even with the menu off, there's nothing that really gets highlighted. But on the new one, the 703S, when you have this little arrow here, so it shows falling edge or rising edge. So I'll just leave it on rising edge. Okay, so yeah, it's nice that with the bigger screen you have more options. All right, so let's go to the next window. So I hit the right key on both. Okay, so now we have English option and Chinese option. Okay, and here's auto off, so I can cancel it. I can 15, 30, 60, 120, and cancel. So it starts at 15. Okay, so that's pretty cool. I like to cancel right now. I mean, you know, maybe sometimes I'll leave it on, but a lot of times I like it off. Backlight, I have 100% just because in the, you know, with the setting the lights, it's just easier to see. In person, I think 80% looks good, and I'll save on battery. I mean, I think that's perfectly fine in person, but on the camera, I'm just putting 100%, okay? And then more measurements off. So this, I have 3 of them here, and I turned on the last 3. So now I have being minimum, and I had maximum before. Now I have RMS as well. So I have min, max, RMS, and then I have the VPP frequency. Okay, and the PRD, it must be period, right? So that must be like frequency, like 1 over, that must be the time for a cycle, okay? Now, on this, on the new one, 703, we have our trigger source. So because we have 2 channels, this, we need this one, okay, channel 1 or channel 2, and then trigger position. So that's kind of, so trigger position, I really don't know how to use that actually, because it doesn't seem to do anything. So I have to ask them about that. So like I said, this is an early unit that might not be working yet, but I would imagine you'd hit that and then you'd be able to, you know, say what percentage of the screen you want, 50%. But that other thing earlier that we saw where we can move the trigger, that seems like a duplicate of this. So that's something I'll ask them about. Okay, let's go to the next window over, and next window over on this one. So on this one, we're back to a language. Now we have that, Chinese or English, so same thing there. Now they both have calibrate. So once you warm up a meter and it's warm, it's in the environment it's going to be in, you can hit the calibrate. I think this is where you leave all the probes off of it and it'll self-calibrate, okay? It'll self-center the frequency. Like this one looks like it's off a little bit. This one probably needs to be calibrated. So you know what? Let's go ahead and do it. Okay, now, okay, calibrating, don't input signal. Okay, so that one's calibrating. Maybe I'll just go ahead and calibrate this one. Why? Okay, unplug menu. And then I hit menu. So this one said make sure you don't. This one said unplug. And so this one you can watch it calibrate. This one just kind of shows you a busy signal. So kind of interesting, different ways to do it. This one, you don't really know how long you're going to be waiting. This one you go, okay, I got time to get up and go get a drink or something. But in both cases, I guess on the camera we can measure how long this is taking. It feels like it's going to be about 1 minute to do it. It's nice that updated, you know, instrumentation in today's time, 2024, right? That we have instruments that can self-calibrate. I mean, this has been happening for a while, but isn't this really nice with today's electronics that they can do this? There we go, success. And you know, part of the calibration, it's also checking to make sure that everything's working properly, right? By the way, that is a big function of calibration. It's not to tune your meters or instruments. A lot of times it's just to make sure that your equipment's still working properly, because today a lot of equipment will maintain the, you know, specification for years, but still you don't know if something's starting to fail. And when you do these calibration processes, you'll find those corner cases, those issues. Is this one done now? Okay, I think it's done. So seemed like the new one finished a little quicker. Maybe it has a faster clock in it. But okay, so I left all the measurements on. Maybe I should go back and turn off some measurements, okay? Okay, I'll turn those off, go back, and I mean, it just kind of looked kind of busy. Now, calibrate off, default off. Okay, now this default or the reset, I think, does the same thing. This just takes it back to factory settings. So if you've messed up everything and you want to set it back. So I'm not going to push those because it's going to change everything I've set. USB enter. So I think this one, if I just hit this, it's looking for a USB when I hit press F2 to exit because I don't have anything plugged in. So that's kind of interesting. Let me go back to that window. And then this one has storage enter. So if you want to go look at your storage, USB F2. So same kind of thing. This one just called it USB. This one called it storage. Okay. Let's go back to that. And now we got to version. If I hit this, it's already telling me the version, so nothing happens. And you don't see an arrow here, so I can't keep going to the right. So it doesn't let me wrap around. So we did 3 windows, and now I can go back. So this is window 1, window 2, and original one. So we got 3 windows. 3 times 4, we have 12 different, options, menus down here. So this one, we can still go another one. Okay, auto off, that's off. Backlight, 100%. So we had those earlier on this one. Run mode, normal. So it has this high or normal, high speed operation. So that's kind of interesting. Here, I got to go back. Let's get back to that. All right, well, I have my lights down. I want to show you this version thing. A version over here doesn't do anything, but over here it does. It pops up with that. So it does give you the information about all the, the app, the boot, and the serial number. So yeah, the app is version 1.1. So yeah, big hopes for that app coming out, some cool things in that thing. But yeah, there you go. Okay guys, I have a scope probe put in here, and we're going to look at the output functions. You can see a wave going right now. I'm connected up to the output, the waveform output. So let's take a close look. I'm going to zoom in and try to get the lighting so you can see better, okay? All right, that looks better in camera. Hopefully it looks good when I edit this thing. So I'm on the menu window here with the output settings, okay? So let me go ahead and click on that. And I'm showing you 2 different ways to hook up the generator, I think. We're going to try this together. Okay, so I select that thing, and then if I change this to pulse, okay, let me close the window, see if that worked. I have to deselect it to get out. Yeah, so it looks like it's set up that way. Here, I have to get back here, and let's go to time. Exceeding time limit. Okay, let's go the other way. There we go. So we got that waveform. Okay, let's go back to the menu again, and got to go through a few menus to get to the output setting. Okay, so go back to output setting and select that again. It turns yellow, and then we have that waveform, which looks like a sinusoid to me. Okay, do that, and then get back out of the menu, and there we go. There's our sine wave. Okay, so this is how you can set up your waveforms. Now, the frequencies, here, let me see how high we can go. That's pretty low frequency. Select that, turn it yellow. Okay, and then I just have to hold it down, or click on, oh, okay, 5 kilohertz. From this menu, that's as fast as I go. Now, see, I have to deselect it, and then get out of it, and then it changed it, okay? So if I change that again, now I can go back this way and zoom in on it. Okay, there's that wave. All right, so go back to that menu. I'm gonna go left this time. You probably can't see what I'm doing, but I'm going left this time. And this is actually the first time. See, if I go to the menu, I go left, and there it is. So that was a quicker way to do it. Okay, so now let me go back to that window, and then voltage. So select that, and I have 2 options, 1 or 2, okay? So what I wanted to show you is deselect that, go back up here, and I'm gonna select that. Let's see what waveforms we have. There's a triangle, and we're back to square. So square, and then output, which really a square and this one, the pulse, is the only difference is duty cycle, right? So it seems like they could have just given us the option to do the duty cycle. See, there's no option in either one of those. So, okay, so this is one place you can go to output and control that port. Okay, now let me show you another one. So exit out of that. Whoops, you got to deselect it, which I'm going to make some of these notes and pass it on and see what they say. You know, see if they want to change any of these things. So that's one of the things. Okay, now see, there's output setting. Here's more apps on this side. So if I go to more apps, can you see those things? Hopefully those show up well in the camera. Okay, so just want to try to give you a good look at that. That's why I turned down the lights. Okay, let's go to more apps. And we have this image view for images we've stored on the unit. And we have generators. So let's just go to the generator and select that. So see, this is a nice menu. This is like a lot of, you know, ARB generators. And there's on and off, right? So here's on and off. Here's how I turn on and off generator. Problem is, and I'm going to show you when we're done here, I don't know how to get out of this window once I'm in. The only way I know how is to hit this mode button. And what that does is it throws me back into the menus I'll show you in a moment, but it changes my default settings. So I think this is a bug that there's not a way to exit this window. So essentially, my generator is always on because even when I exit this, it turns back on, I think. So we'll check that when we get out of this, okay? So over here, I can go down arrows and choose different waves. Now, if you notice, sine wave, 2.5, but there's no way for me to change voltage in this selection window. So that's too bad because I like this window, but I can't change frequency or the voltage. Well, I'm sorry, I can change frequency right here and I can change duty cycle here, but I can't change voltage. So yeah, that's an issue, right? Now if I come down to square wave, now I have a duty cycle option, and the duty cycle will go up to 90% and down to 10%. Yep. Okay, so then let's go to triangle. So there's the triangle waveform. Half waveform. See, I can turn it on and off. I can't change voltage. I can change frequency, and I can't, there's no duty cycle option, so these don't work in this window. And then full, if I go left and right, I thought about doing that. Oh, actually, you know what? Yeah, look at that. So if I go left and right, I can change frequency this way. Oh, just from 50 hertz. Oh, that's interesting. It toggles between those two. 58K. But I can also go this way. And I can go up to, let's see how high I can go. If I hold it down, okay, I can go to 294. Now, what if I go with these arrows back and forth this way? Yeah, it changes from 294 hertz to 294 kilohertz. That's interesting. So, yeah, going this way, it'd be nice if frequency was controlled by this or voltage was, and then I could control. But yeah, if I use here, let's try the up and down buttons. Maybe, yeah, see, that just controls this, right? But if I could go to the right and select one of these things, that'd be cool. So I just wanted to show you this. This is one of those things where I think there's a little bit of a bug, and we need to see if we can clarify this. And every one of these waveforms has a different max frequency. So I'll show you, sawtooth, 10 kilohertz. So yeah, so I just want to show you that. Now again, this is an early unit and they're working on the firmware. And so I think it's kind of strange that there's both the output button and there's this apps button. I think the apps is really cool because I could see them coming out with some new apps. So that's a really cool thing to look forward to. But in the output and this one, you think they would be the same, right? Like square wave, triangle, and half and full. it'd be neat in the other window if they let you control the duty cycle, so the menu wasn't taken up with square and pulse, because really that's the same thing. It's just a matter of changing duty cycle, right? So yeah. And then also when you change these things, it'd be kind of neat to see it change in this picture. But yeah, that's probably asking too much maybe. All right, guys, just wanted to show you that. Okay, so the other thing I want to show you is hitting this button. It's the only way I can see to exit this window. And when I do, it exits it. And I have the wave I just left there. But see how the screen's dimmed? Maybe it's hard for you to tell. So I have to go to Menu and go over to where I changed my screen. Backlight, 30%, 50, 80, 100. So it changes that, but it also changes, watch, the backlight time off. So 30 seconds, 60, 120 off. So I have to go back and redo those. I think I'm not sure what else it changed. I don't know if it changed the time base and voltage or anything else. I wasn't really paying attention to that. But you can see my generator still on, even though, you know, if I try to turn it off and exit this way, it's always on. So yeah, that's something I got to bring up to them, and maybe we'll see some updates. So also on the 703, we have the cursors, right? So on the cursors, if we go to our default menu, like default screen, so we turn it on, hit the menu button, and then go to the left one time, we get cursors. So come over here and say cursors on. There's a horizontal, there's the vertical, push it again, and we got horizontal and vertical. And then one more time goes back to off. So we go ahead, let's turn them both on, and you'll see the change of volts right there, 50 volts, change the time is 2 milliseconds. So if you notice that when I go horizontal, we get change of volts, 50 volts, vertical, 2 milliseconds, and with both of them, I get both cursors. So that's, again, it's just another nicety that we got with the 703S. So now if I go back out of the menu thing and I go to cursors over here, then this is where I can control them. First, the top one is red right there, and that's one I can control, okay? So I can pull him down, and you can see the voltage there changing, 33 volts. So then I just toggle it again. The bottom one's on, so I can pull that guy down, and then I hit it again, the left one, so I move that around. If you hold it, it goes pretty fast, so you know, and then hit it again, and now the right one. So there you go. And so that's how you can use the cursors, and then turn them off again. Remember, just hit the menu and go to the left one screen, because there's 6 screens here. I don't know if I actually went through that, but here, let me just go. All right, I'm going to go through the windows kind of quickly, just to kind of show you all the windows. Okay, so first I'll do the one on the right, and there's window 2, window 3, so there's 3, and then I have to go back the other way, because the arrow, you know, the arrow shows, okay, go this way, go that way. And on this one, it rolls around, so you get arrows in both directions all the time. So there's window 1, window 2, window 3, 4, 5, and 6 windows. And then we're back to where we began. All right, guys, I'm going to show you the scope functions, but first let's go to what? They both have multimeters, right? So since both of these are high count meters, we're going to look at some measurements just to see how quickly it captures them. Because in the old days, the high count meters, you know, it would slow down the meter a little bit. But these days, things are a lot faster. So far, these things seem like they react pretty quick. But let's take a look. So there's DC. Let's turn this to AC. Okay. You know, I was just wondering, I was looking for hertz. Oh, yeah, here it is across the bottom. So it gives you max, min. Well, this one gives you max, average, and hertz. So this one gives you max, min, and hertz. Oh, that's interesting. They changed that up. Now, I wonder if we go in the menu. Oh, okay, in the menu, we get new things. Okay, we got language again. I'm sure that's going to be Chinese or English, same as before. auto off, it's off, so it's just stored from the other, scope menu. Backlight, 100% same thing, and UART. So, it's calling it a UART now. On off. Okay. Now, let's see if you can save in this menu. So here, let's turn off the menu. Now, normally you can hold it, right? Or you can hit the menu, hold it down. Yeah, look at that. And it even shows, it was neat. It showed the number of the picture. So that's nice. If you're in a lab taking measurements, remember that number, write it down. That way you don't have to try to correlate things with time or something like that. But yeah, that's pretty cool. Okay, and I'm pretty sure you could do that with the old one too. Yep, and it says okay. Oh wow, I held it long enough that it stored 2 pictures. Okay, so now with the 702, you do get temperature, and I'm not sure why. I'm going to ask them about that, but they did take it off of this one, so I don't know. Maybe they needed that input for the second scope. I don't know. And of course, they default to auto range like most auto meters, but you do have the manual range option. So sometimes that's faster when you're taking measurements, or like let's say you're looking at 12 volts or something, you want to plug it in and see it real quick, or inrush current or something like that. You can set it to that so this meter doesn't have to figure out what's going on, and if it sees a signal rapidly changing, it's running through all its ranges, and it's harder to watch and read. So it slows it down too. Yeah, and look at all the digits you get with the 25,000 count. 10,000 counts, nothing to sneeze at. It's pretty nice. Okay, hold it down and it goes back to auto. All right, guys, I have these high precision resistors. They're made by an old company that was referred to as Genrad, General Radio, out of Concord, Massachusetts. Just high quality stuff they made. And so anyway, let's just go ahead and plug it in here and see what kind of reading we get. I just want to see how fast the display changes from 0, and it'll probably take a moment. So these things are cool. They're out in my lab, so yeah, it might be changing temperature. I'm not sure. Anyway, okay, let me hold that. See if I can hold that, lock that in. Oh, that's interesting. You know what? I noticed that once before. When I put that in there, okay, I hold it. It holds, right? But if the measurement changes while it's holding, so I'm not sure. So that might be an auto hold. Some holds, if it changes with it out of range, like into the next range, like, they're auto ranging, right? So if it goes from one range to the next range, it'll capture that next one and hold that. So I wonder if that's what's happening. Okay, let me turn off the hold. Let's try it over here. Now we got that extra digit, right? So 0, 10, because we got 25,000 counts. Let's try to hold this and see if we get the same kind of thing. Nope, that actually holds. So maybe what we're seeing is a bug in the hold on this one. Okay, I got a 100 ohm resistor. All right, let's try this one. Okay. Wow. Okay, it held that one. The 10 ohm scale just didn't like. Okay. I feel like I want to go back and give it another chance. But okay, so that's 100 ohms. Let's go over here with 100 ohms. Take off the hold. And it's almost identical. Look at that. Well, no, that's 0.4. This is 0.6. All right, now remember that last digit is always the one that's totally suspect because of the tolerance and so on, right? All right, I always hate that when, it's like, well, what measurement's right? they're usually always right. I don't see reviews where meters are out of calibration, but this one is 1% tolerance. So if this was perfectly 100 ohms, that anywhere around 99 to 101 would be correct. So that would be totally good, right? And see, then there's that +3. So that last digit can go up and down 3 counts. So it can go up 3 numbers or down 3 numbers and still be fine. Okay, that's the range when you're in the 100 ohm range on this one. When we go in the next range, which we're going to do in a moment, it's going to get improved to 0.5%. Okay, so keep that in mind. And then there's 1.5 for 10 meg and above. Okay, so for most of the ranges, it's 0.5%. This one is 0.5% now, so it's twice as good, up to 250 ohms. Okay, because it's a 25,000 count, so you can go higher before it goes to the next range. So you see the ranges are all by 25, where on a 10,000 they're all by 10s, and most meters are 6,000 counts, so that's why there's 6 ohms, 60 ohms, 6K, that kind of thing. So then we go to 2.2%, and the last digit is at 0.3%. So in a case like this, in low ohms, the last digit, even on this one, so the last digit, it's 0.0. So see, it's not as bad. So the digit right after the decimal point has good tolerance, good accuracy, where on the lower count meters, they don't. All right, so now that we got that covered, so we can see we're totally in range. This one's almost perfectly dead on if that's a perfect 100 ohm resistor, right? Okay, so let's go to the next one. So this guy is a 10K ohm, all right? Let's try that. And let's try this one first. So, whoops. Now 10K ohms, all right, so 10K ohms is still within the 25 count. It's very close to this one. So is it still in the range or is it in the next range? Let's see. Take it off hold. And wow, when I took it off hold, it just instantly went to 10K. So that was very fast, right? Okay, so 1004. So now remember that last digit. So now the 10 point, that digit's got more accuracy because it's the last digit is plus or minus 3, right? So plus the tolerance. And so I lost it again. See, I'm wondering if am I hitting something when I do that? Or is this hold feature just kind of suspect sometimes? Okay, I'm going to try not hitting buttons. Okay, that might have been me hitting a button with my big grubs. So, okay, we'll blame that on me. But we'll keep track of that, just see if that comes up again. All right, so, man, look at this. All these digits. So that last digit, okay, let's say we don't even care about that. Look at that, 10.00. So that's the beauty of a high count meter, guys. All right, well, okay, so I'm going to go ahead and hit the hold because we're going to test that hold function too. Okay. See, that's interesting. I wonder if it's a noise issue. I don't know. Okay. I don't know how sensitive it is, but yeah, if you're really careful, you can remove it. But man, these things, I'll tell you what, for how old these are, there's still a lot of spring in those things. All right, so now what do we have? We have 100K. And by the way, I haven't been reading off the tolerances, but it says 0.025. So, I mean, this should, they should be super accurate, right? 3 milliamps max. I don't think these meters are going to put any more than that in there, right? So, let's try this. And I'm going to take it off hold this time to see how fast it goes from 0 to 100K. And that was pretty darn fast. So, pretty fast reading. Now, takes just a moment to kind of settle in. Okay, so we're going to hold that. Okay. And let's see, we're going to do the same thing on this one. See how fast it is. And I think they're fast. Again, extra digits are very nice. Okay, we'll hold that. And I'm going to try to remove it. Yep. Okay. Well, nope. See, And I didn't touch anything, so I'm not sure what's causing that. You know, when you don't have when you have nothing plugged into the plugs here, and when I'm pulling it off, it's going into really high impedance, right? Because there's open circuit. So that means, so it could be that they're just really sensitive. It might mean just how fast I see, you know, how fast I, yeah, see, that's me. That's just me causing little arcs and sparks in here. I mean, they're not really, you know, they're not nothing you could see or feel, but it's just the current that this guy wants to put out in resistive mode is causing little glitches, which is resetting the auto. So it may be a little capacitor on the input, but then that slows things down because now you got a capacitive input. So, all right, guys, I'm going to show you this. This is a capacitor box. Here's the values. You can see somebody put it like the 10 measured 13, 20 measured 20.4, 40 measured 52.4. So you can see it. I mean, that's, you know, the 80 measured 100. Okay, so that's the actual measurements. The actual tolerance of them, they go from -10 to +50 with temperature and, you know, lots, codes, and all that stuff in production. But the actual measurements somebody took, I'm sure at room temperature, were these values. Okay, so if you want to remember that, 13, 20, 52, and 100. Okay, now this is from Cornell Dubilier, a capacitor manufacturer. Okay, they make a lot of good capacitors, and maybe I'll see if I can get some of their capacitors so we can look at them. So here, let's go to capacitor. Okay, I'll plug this guy in. And they're all off, so it's open circuit, okay? So I'm going to put in the 10. Took just a moment. Okay, so this thing, whoever measured this back in the day when they did, said it was 13, okay? 13 microfarads, so we're measuring, you know, close to 15. All right, so let's see if I can hold that without interrupting things. Maybe if I turn it off before I open it. I'm not going to do this with every capacitor. I'm going to run through the list in a minute. But, whoops, here, let's go to capacitor. Oh, okay, now I got to turn it on. All right, it looks like it might end up settling into near the same value as the first one. All right, and then the capacitor tolerance in both books, okay, goes to, so it's the same in both meters. The tolerance is ±2% and 5 digits, okay? So that's the same in both. Okay, so 2%. So I don't know what the value is today, and like I said, I just took this out of my lab, which is kind of cool. Might be right, but man, it's interesting how they both just nailed it, right? Okay, now I'm going to go to the 20. Okay, I'll hold that and take it out, try to switch over a little faster. Take it off hold. Wow, it seems like if I sit here for a moment, it's going to end up being the same reading again. The method of reading capacitance, even though this has higher count, so I thought it had a different chip. I thought it'd read capacitance and everything different. God, they're very, very close. Look at that. Now, I could add 10 just for fun. See how fast or whatever it changes. Okay, now add the 40. Okay, so it's around 91 microfarads. Okay, I'm going to go ahead and hold that. See how fast this one gets to that same number? Wow. Pretty quick. Holy smoly. Man, these meters are pretty much dead on. I mean, capacitors, you know, you always know the tolerance of capacitors aren't exact. There's, like I showed you, the tolerance is kind of all over the place with capacitors a lot of times. Electrolytics especially. So, but wow, this is doing a good job. Okay, now I'll turn off the other two, just read the 40 by itself. And remember, it was 50, what was it, 52 or something on the back of this. It was 52.4. So in this case, these guys are coming in very close to whatever somebody measured there. So I'll freeze that. Whoops. Is that me touching it? Okay. So it looks like it was creeping up just a little bit there. Let's see what this guy's going to do. I suspect it'll be very close to this meter, which it is. Wow, look at that. Man, that's crazy. You know, and these are, you know, we're up 50 microfarads. That's pretty fast, I think. Now, here I can go to 60, add that. 150. Let's just max them all out. All right, let's try that reading. That looks pretty settled in, pretty close. Okay, well, I was going to say there's some difference this time, but now this one's just counting on. I think what happens is when it first takes the measurement, whatever voltage it applies, it sits there and drains off until it gets a good reading, and then, you know, it seems like it starts high, right? And then, okay, but, well, in this case, it's off by, well, okay. Guess we wait long enough, it'll probably end up being just like this guy. Okay, so then if I click off all these guys, just leave the 80 there by himself. Feels like it has to discharge, right? So what was the 80 measuring? 10, oh yeah, it was measuring 100.5. So almost, man, so this one's coming, boy, that's just what whoever measured this one was. So in this case, it looks like it's dead on. Okay, let's go back over here. Wow, okay, they're both just dead on there. So, man, not bad at all. All right, I thought we'd do a continuity check, and yeah, I do like these leads. I'm trying to talk a little bit so you can kind of hear how loud that is and the tone. You know, I kind of like the tone. I don't know, some of them grind you a little bit more. This one, I don't know if it's a little lower pitch, but yeah, I kind of like it. So you can see the needles moving around. You can see how fast it goes from open to short, and it's showing about 0.01, which just makes me wonder, like in the ohms, wow, it does a really good job of zeroing out the impedance of the leads, right? That is pretty amazing. I find some meters are able to do that, and it always makes me wonder how you know, somehow I think they must lower the current in low ohms until they get the lowest readings they can. So it's got to be a super sensitive reading. Oh, you know what? Just as a diode test, I'm going to grab a diode, but just to test the sound part of the diode. There's no sound. Now, some people like that, and some people want to hear a beep. I kind of like the beep. when it's shorted, I kind of like to hear the beep, but it is going to show you the voltage, and you do get the, you know, that analog meter seems to be pretty fast. Have you guys noticed that? I mean, it does just go boink, boink. It doesn't go like, it doesn't race around. It just kind of has one reading, and then, so it kind of just goes along with the display. So, yeah, a lot of times you feel like the analog displays are just for looks. Because, yeah, they've been carried along with multimeters so long that people expect them, but I don't know how useful they are anymore. Whoops, just turn off the hold. Okay. Yeah, I think it sounds about the same. They're both very fast, and they don't have that loud of a sound. Now, people, like, I work in an office with another guy in the office with me, and I'd bug the crap out of him if I was sitting there buzzing out a board in my office. I'd have to go to the lab, because unless I could turn off the buzzer, right? So in the diode mode, let's make sure this diode functions the same way. So it's quiet. So unless I'm getting a short in the lab, if I'm just going around taking ohm readings and that, I'm going to be okay. It's just when you go into the short or the buzzer mode that you get the sound. So I think that's why in diodes they leave it off, so somebody could check out a board, diode settings, resistance, and all that without driving their cube mate or office mate crazy. Alright guys, look at this big old transistor I have. Pretty cool, huh? I think they call this this looks bigger than a DO4. DO4 is a big old nut thing looking. This might be a whatever it is, DO5, DO6 or something like that, but it is a behemoth. I've had it for years. So the collector is this pin here tied to the metal case, right? Often the case is collector, sometimes it's emitter, but I think most often it's the collector, okay? Pretty cool, right? So the base is the next one, emitter, and it says it right on the transistor, so it's, yeah, pretty neat stuff. Old military style, you know, mil pref type part probably. I used to buy stuff in auctions, and I'd get a lot of leftover parts and stuff like this. So, okay, we are in diode mode. Let's put the negative one on the base and go to positive, or the emitter. And it's open, it should be. Let's go to the collector, and that's open, and it should be. So let's go to the emitter, and we'll go to the base. Okay, we see 0.54. Let's leave that there, and let's go to the collector, and 0.52. Great, that's what it should be. Okay, now, okay, I've got this one set in voltage mode, which that's great. So I want to check how many volts are coming out of this to check diodes. So 3.2 volts. That's on the high side of, on average, right? High side of average. Some meters are just below 3.27 or whatever. So this will light up most LEDs for those guys that like to watch LEDs light up. It's a diode checker. Yes, LEDs are diodes, but the thing that fails most often is rectifier diodes and transistors. Anyway, LEDs don't fail very often. So, but people like to light them up in reviews because it's cool. Okay, let's go ahead and put this guy in diode mode. And we'll do the positive on base. We know this transistor is good, so we're not going to bother testing to see if it's shorted. We already did that. So 0.536. That's pretty close to that 0.4 something, 5.4 that we saw over there, right? And there's our 5.2. So, man, these guys are working very close in diode function too. But just to be sure, let's put this on volt mode and check the voltage output of this one. And yeah, I mean, yeah, so that 3.2, I'm happy with that. You know, some meters go 5 or even higher volts, but you know, 3.2, that's a good number to hit. Anything around 3 volts, I think, is, you know, really good. High voltage diodes will be over 2 volts, and also optocouplers, sometimes they fail, so you want to check the diode inside that, and that's around 2 volts too. So yeah, looks like we can check just, most LEDs or diodes. Now, just one thing, just as a note, this guy's battery is running down. Now, I've had this for like a year, I think, and I've used him, not a lot, a little bit here and there, but I don't know, when I charged this one up this morning, because this one looked like it was already charged, but it could be that this one was, even though the bars were across, once we start working with it, it might just drop down faster. So, because batteries will kind of float charge when they don't have a load on them. So once you start loading them down, though, the voltage will drop quick. So yeah, this one may not have been charged as much as that. So I'm going to charge both of them up again, and then I'll pay attention to that. So we'll see if that's something. It's an 18650, so we could always go inside there and change it out if the battery is getting tired. All right, so what we have here is have this set of leads connected to this meter, so the 2 meters are connected together, and then this one going to the connection here. So both meters are reading the same, essentially the same voltage, right? Well, first of all, let's cover the tolerance. All right, so this book is for that one, the new one. It's 0.05%, which is pretty darn good, and plus 3 digits on the last digit. Okay, so 3 counts. And so this one is 0.5, so 10 times better over here. 0.5%, 3 counts, 0.05. So there we go. So the last digit can be, 3 counts off, right? Plus the tolerance. So anyway, it looks pretty darn close. I mean, they're all hitting just about right. Okay, now this is the Extronic power supply. It has 3 programmable outputs, and that's M3, I think. Yep, that's the 3rd programmed output. So I want to jump that down to, now, by the way, you see the 0? So 25,000 count meters, so we have an extra 0 here. So let's see if I just dial this down a little. Well, I'm going up, I guess. So if I go up, see, we've got 2 digits on each one. Now if I go down below the 25 volts, let's go down to about 20 volts. And so we get the, it says 25,000 counts, but really it seems like, okay, it's around 20,000 counts, right? Because we get the 3 extra digits over here, right? So that last digit, 3 counts off, we don't care, it's 20 volts even, 20 volts. And 3 counts over here, so that could be equally, as 20 volts, right? So let's see, let's just creep it up. I want to see where this switches over, because it's interesting that we lost that digit before 25 volts, I thought. Okay, now the other thing, on the analog meter, because this is 25,000 counts, we still have a good resolution up to 25 volts, and that would be the same as 25 millivolts or any 25 anything, right? And over here, it's gone to the next scale, the 100 volt scale, so we get a lot more resolution on the analog scale. So that's another advantage of, the high counts. All right, looks like it is going 25,000 counts. Then, yeah, okay, then we lose it. Now this one's gone to, well, that's interesting. Is that a 250 volt scale? So 25 to 250, I guess. So now you don't have very much resolution. 100 volt scale. So, okay, so there's trade-offs. But like I say, those analog scales, I mean, those scales, they're more like digital, like quartz watches versus an analog watch. So again, I don't know how much value. It's just something to look at. But, all right, so here, let me hit M2, which is a lower voltage, just to see how fast they react. That's kind of what I'm showing this for. Not for accuracy. I feel like they're always accurate, right? But it is interesting to see how closely they track. Wow. Okay, so, but now we'll go back up to that one. Yeah, so I mean, I think they're pretty quick displays, right? Okay, now we're going to jump up to even a higher voltage. Okay. Yeah, I think it's pretty cool. Okay, now let's just jump down to that lower voltage. And you know what? I'll turn it off and see. Well, here, let's go to high voltage. I'll turn it off. And this one still hasn't dropped down into the millivolt scale. Over here we have. So it's still waiting. We got all these digits. So yeah, there's just a little bit of a charge on the output of the power supply. Okay, now flip it on and see how fast it jumps up. Yeah, so anyway, I was trying to give you an idea of what 25,000 counts looks like compared to 10,000. 10,000 is pretty darn nice too, right? So we'll jump back down to the low one, and then I'll bring the voltage up as we do, because like, let's say if we're looking at 5 volts, we have lots of digits on a, you know, on a, well, a 6,000 count, you'd have that too, but 6,000 count, you'd already lose 2 digits here. So, you know, 10,000 count is still a lot nicer than 6,000. So if you're all the way up to, you know, 10 volts, we're going to lose a count. Okay, a little bit above. Okay, there we go. So, yeah, so 10,000 count, I still like that a lot better than 6,000 count. But 20,000 count, man, the higher count is just nicer, I think. And if it doesn't slow down the meter by having those counts, that's a big bonus too. All right, so we're looking at current, and you know, just to kind of give you everything, the new meter is 0.5% in, like, yeah, both DC current modes, the high and low, and the 702 is 0.8% in the lower range, and in the higher, you know, the amp range, it's 1%. So it's actually pretty darn good in the lower range though. So now this guy, I've got it set for like 3 milliamps, but you know, the power supplies generally aren't super accurate, but especially in the low range, but I was surprised I could get a setting that good. So I really like that. But these guys are saying it's more like 1.3 milliamps, and they're pretty much agreeing. They're pretty darn close. So if I take up the current just to 13 milliamps, again, they're very close, right? So let's take it up to 23. I mean, they seem to be tracking very well. So, and let's go up a little bit higher. Okay, essentially 31. And so this guy, it was just a few milliamps off to begin with, unless both meters are. So, but yeah, it seems like they're tracking very well. So pretty cool that you can read that low milliamps on the meters. All right, guys, I got the displays turned down to 30% because I think it was easier to see the menus I found. But okay, hopefully that looks better. I've got the RMS and the frequency reading right here. Right now this says 207 millivolts. I think it's because we don't have enough voltage to get a good reading. So what I've done is I set this up to 10 millivolts at 1 hertz. So real low frequency and real low voltage, just to see if we can get something low frequency millivolts. The reading's wrong. You know, it says 0.23 hertz, 207 millivolts. So, okay, so we're off a little bit. And I mean, we're off a lot, but you can see it's 10 millivolts per division. And we're, you know, so at least the wave shape's right. It's just the math is wrong because there's not enough there to get a good reading. So over here, same kind of thing. It's RMS is 0.19, so it thinks it's 190 millivolts. And you notice it's 0.19, and over here you got 207.8 millivolts. So if you notice as we go through this, if you can see this reading, it's just a better reading, 207.8 millivolts versus 0.19. Okay, and 0.23 hertz, and over here it's 2.8K, so that's way off. But we're also in ×1. The probes over there are ×1 for this, because low frequencies, about the only time you want to have a ×1. I mean, there's other times, but low frequency and low voltage. When you do that, you're limited to 1 megahertz bandwidth. So we're going to check the bandwidth. We're going to go high frequency too. But I just wanted to show you, because people always ask, can you read 10 millivolts or something? And you can see it on the screen. We're 10 millivolts per division. Over here it's 20 millivolts. And that's as low as I can go. So you can go a little bit lower. One thing else I want to point out, guys, if I move this trace down, like if it's down here and I want to move it because I can't see all of it because of this, then I can just push and hold the move and it puts it right back. Now the trigger will stay down here. So if I come over and hit trigger and just hold it down, it'll pop up in the middle too. So it's kind of like, the larger scopes where you can hold buttons down, they do it. Now this one over here does not do that, okay? So I'll just show you real quick. If I pull this down, waveform's down there. If I hold it, nothing happens. So, and the same with the trigger. So, so they have, made the GUI a bit nicer on the 703. So just wanted to point that out again. Okay, I'm going to put a different frequency on this. We're going to take a look. Well, actually, you know what? Let's just go to a square wave since we're here. Let's see what that looks like. Okay, looks so funny over here. And this actually looks really good. I'm not sure of that. I wonder if it's a probe compensation. I thought I took care of that on both probes, but maybe I didn't do a good job. I don't know. I'm going to have to check that out. You know what? We're going to go to a higher frequency and we'll see if it still looks like that, and then I'll do the probe compensation again if that's the case. But I thought I'd check. And also in ×1, probe compensation is really not a thing. Or if you're ever trying to compensate your probe and it's not really doing anything, it's probably because you have it at ×1. Okay, but yeah, look at that, pretty nice. Still same RMS, same frequency, so still can't read it. Or here frequency went to 1.5, 2K, it's kind of bouncing around. RMS is still the same thing. All right, and you know what, since we're here, before I go to a higher frequency, let's just do that higher amplitude so I can, well, you know what, before we do that, sorry, let's check out some different wave shapes. Let's do a triangle. Okay, it's looking pretty good. Over here, it looks just slow, right? It looks like, yeah, that surprises me. I wouldn't have expected that. Okay, and what do we have for arbitrary waveforms? A heartbeat? It's kind of hard to see, right? It's kind of hard to see at this low amplitude. So let's just go back to sine wave. And, well, actually, I'm going to go to square wave since that's the one that didn't look right. So let's go to this one. And then let's increase the amplitude from 10 millivolts. Let's go, actually, I'm going to go up by 10 millivolts each time just to see if we start getting a better wave shape over here. Still, we're not getting the correct RMS readings. That has not changed yet. It might be because the frequency is so low that it just does not like that. Okay, let's go up a couple more. I'm going to go to 100. Yeah, I think it's a frequency thing. So you know what? Let's go to frequency. And let's just see how high we have to go. There's 20 hertz. 40. I'm going to go to 50 hertz. I'm not sure if it's getting any better now. So let's go up a little higher. Okay, now maybe. Okay, so I'm sorry, we're at 10 hertz now. I was, you know what? Did I say 1 hertz before? I was at 1 hertz, so now we're up at 10 hertz. So That was really low. I'm not sure what I was saying before. Don't remember. Sorry. We're at 10 hertz. Okay. So that was very low frequency. 20, 30. Yeah. Now it's looking pretty good. And also frequency 30 hertz. So it's starting to read appropriate frequency. And 30 hertz. So there we go. And it's reading 0.1 volt here and 988.2 millivolts. So it does look like it's starting to read pretty darn close to 100 millivolts, which is what we're set at. So it looks like at 30 hertz, 100 millivolts, you're getting really good readings. Now I'm going to go back down in amplitude because I think it was more the frequency than the amplitude. So let's go back down. There's 10 millivolts. Okay, 20 millivolts is the best I can do here. I can go to 10 millivolts here. And you know what? That looks pretty darn good. Okay, the hertz is right. The frequency is right. 30 hertz. 30 hertz. And the RMS over here is 0.01. And RMS is 99 or whatever 0.2 millivolts. So looks like they're both right. But you notice you get more, better reading here. All right, so let's go on. So that's pretty good, right? So we can get down to some, 1 hertz. You can still kind of see it on this one. This one looked kind of funny. 10 hertz were good. 10 hertz all the way down to 10 millivolts. Well, we're at 30 hertz right now, but I think if I go down to 20, down to 10, yeah, 10 hertz, 10 millivolts were good. And we're still getting good readings. So yeah, I think that's pretty impressive, right? Okay, we're going to just jump up to 1 kilohertz. All right, we'll go 1 kilohertz. Okay, 1 kilohertz. And we're still at 10 millivolts. And I'm going to go to 1 volt now. 1 volt RMS, I guess. Okay, we're off the screen. I'm going to hit auto. All right, I like this one better. See how it moved the cursor? I can come to move and hold it down. It puts it where it's supposed to be, but I got to get a trigger, same place. So I'm going to hold the trigger down. Okay, good. Back in action. And this one over here, we can go and kind of blow the waveform a little bit. Did a pretty good job, but not as good as we could. We want to fill up the display as much as we can. So, all right, everything's looking great. We're getting 9.8 volts here. All right, so I don't know why we're getting 9.8 volts. That's funny. Here, let me get some more cycles in here, see if that's an issue. Man, that RMS voltage is way off. Holy cow. It just went south because it says 5 volts here. It should be half a volt. I think it changed the, no, it says 1x. All right, you got me. Something bizarre happened. I'm going to hit the auto range again, see what happens. Auto range again here. Wow. That's a serious problem. All right, I don't know what's going on. That's a firmware issue. It was doing great until I hit the auto range. Here, let's move the cursors back where they go. Trigger, hold that down. Holy smokes. Okay, I am going to go switch the probes to 10x because we're going to go higher frequency. All right, okay, I switched the probes. Let's hit the auto range on each one again and see if we get something different. All right, I don't know what the heck, but this one's reading correctly now. Wow, okay, and every time it moves the cursor down here because it's expecting 2 channels and yeah, I think that's a mistake too. If there's only 1 channel, it should center it. So that's a note that I have to give those guys. Okay. Hey, you know what's interesting? I didn't even have to click to hit move and then hold it down. I just held it down. It never switched from trigger. It's still showing trigger. And then I held trigger down and it moved that. So, okay, I like that. So I don't have to go move and then hold it down. So we're going to pay attention to that. And this noise spread's a little bit too small. So, okay, there we go. 986.9 over here. And over here, 0.97. 1 kilohertz and 1 kilohertz. So we're all good to go now. That's kind of funny that it's a capital Q. Capital F, R, E, capital Q. That's just a mistake. So anyways, okay, so now let's go to a higher frequency, guys. I am going, well, you know what? Before we do that, let's do some other wave shapes just so you can see. Triangle, no problem. There's not going to be a problem with any of this stuff at this point. Okay, even the heartbeat looks good now, right? So everything looks good once you bring up amplitudes and frequency a little bit. That one's not locked in on the trigger as well. Maybe if I bring it up, there's 3 bumps. It's trying to figure out which one to trigger on. This one automatically put the trigger here. You notice the wave shape? Huh. Just noticing that. There's this, wow, okay. It's showing the wave coming off of the center position. And over here, it kind of AC coupled it. So I didn't AC couple it on purpose. Let me see if no, it's DC coupling as far as the trigger. And you know, it's showing the DC coupling right here too, right? It's showing DC right there. So that's interesting. I'm not sure. This waveform is what this guy looks like. So this one is kind of weird. All right, well anyway, let's just move on. That's just comparisons, I guess. Okay, we're gonna go back to square wave because that's where you can really tell bandwidth, okay? So let's go up in bandwidth. We're gonna go to frequency. Okay, there's 100 kilohertz. Let's see what happens when I hit the auto. Okay, great, except for it moved it down again. Jeez. It's pretty fast to fix, but still. And this one's always too short. All right, so we're back. And I can change that one so it looks the same. I could turn on the background grid to brighten this one up a little bit, but anyway, we're not gonna mess with that right now. Okay, so everything's good at 100K, right? Which we expect it would be. So let's just go up in frequency, 200. Well, okay, there's 200K. We're starting to round the edges a little bit. The amplitude's still correct, right? So we're seeing 970. So, okay, yeah, check out the waveforms. All right, this looks a lot better, right? Okay, so let's go a little higher. Okay, the amplitude still showing 920, 92. It's got some noise on it. Okay, there's 2 meg, 3 meg. Okay, now we're starting to drop the value. I'm going to just go down until I see it drop down to 700. Okay, 750. This one's dropped down quite a bit. Yeah, so, okay, we're at 13 meg. And yeah, this one, you know, let's see, 10 meg is starting to look okay. Around 3 meg, 4 meg. Now let's go to sine wave, okay? There we go. That looks good. Now we're going to go up in we're going to go up in frequency until we see the amplitude drop to 0.7 thereabouts. Okay, this one is 0.7. It's already whacking out. So it's 9 megahertz. So I'd say, you know, bandwidth of that one to get good waveforms about 7 megahertz probably. And probably that's probably true in sine and square. Yeah, square wave's already kind of gone, right? So, but square wave over here still looks pretty decent, right? Okay, let's watch this one and let's go up in frequency. 8, 9, 10, 20. Okay, 20, that's the limit on the square wave, okay? The amplitude's about 669, so yeah. So that's, you know, 20 megahertz limit on the square wave for this guy, the 703. Let's go to wave, go back to sine. Okay, sine, back up to 890. So still looking better. Okay, 890. Yeah, let's see when it drops down in this 700 millivolt range. Okay, we're gonna go 30, 40. Oh, it's okay. So I would say 30 it was okay. 40 it just went haywire. We're still, the amplitude is still pretty good, 870, but yeah, it's just not liking that. So about 30 meg is kind of borderline. All right, guys, so I had to pull in another scope just to make sure it wasn't a generator, and look at that. Look at that. Got the old one, and it is showing there's a problem. So it's not the scope right now, it's a generator. One thing I want to point out as far as scopes go, I can do that. I can capture more cycles, and I can see how the signal's been kind of, it almost looks like it's modulated out, but there's no modulation on. All right, guys, so at 10 megahertz, that wave on O1 looks like this one. Yeah, we know this one's low jittery, it's already jumping out, but this one's locked in, and it agrees with that O1, 200 megahertz bandwidth scope. I do want to show you the value of having a lot more samples, okay? So we're going to go to 10 meg. We got to go to a sine wave. Okay, so we're at 20 meg. Okay, now as we go up and we start seeing that jump around, see how we see that wave shape there? That's because we capture lots of bits and we can reproduce that. Where on this one, there's not enough samples, so it just kind of, here, I'll freeze it for a moment so you can see what it looks like. It's just every other wave. So when it's, it's sampling, it's just missing samples. So we don't end up with the wave we see on O1. With this one, we see that. But anyway, that's just because there's a problem and it looks like it's being modulated. It shouldn't be modulated. So let's try something else. All right, we have another generator. That's a 10 meg square wave. Let's see where we are. And this is doing a reasonably good job. It's kind of jumping around a little bit, but I can stop it. And it just doesn't have enough samples to capture it really well, but you can kind of see it's doing a pretty good job. Now I could go, this might be a good time to show you the persistence, because I could go to persistence and turn that on. There we go. So that's kind of persistence, and then we could stop it. So it's kind of showing some of the wave shape. So it's gathering a whole bunch of samples and keeping them on the screen. But okay, I'm going to put that back to minimum. Get out of the menu. So anyway, at 10 megahertz, it seems to be doing a fairly good job. And we're over here using the Zotek. Okay, so that's where we are. Now, if I go to 20 meg, okay, now the square waves, like, it's all over the place, right? And up here, that's what it should look like. Okay, so now I'll go to 30 meg. Well, so see this generator, it's starting to, it can only do a square wave up to about 20 meg, okay? But the scope, the Zoyi is having trouble with square waves. So let's go to sine wave. Okay, there's our sine wave. Okay, now it's pretty happy at 20 meg. Okay, let's go to 30. Okay, now it's dropping in amplitude, but I think it's about 790 millivolts. And okay, right there, it's about 928, so it's already dropped a little bit. So it is, the scope is starting to drop down, because when I look up here at the O1, it is right now 960, but if I go back down to 20, it's 1 volt. So the generator's also dropping. So I think this is supposed to be 80 meg generator, but at 30 meg, it's already starting to drop out. So it's like, okay, 40, it didn't drop very much more, right? Okay, let's go look at the let's look down here at the Zoyi. So 30, and then we go to 40, and it's starting to get whacked out. So, you know, 50 meg, it's, I wouldn't say that. I'd say it's more like a 30 meg, because at 40 meg, it's really having trouble. And even though the generator is also dropping in amplitude, when we go up here and look at that one, at 30 to 40, it just drops in amplitude slightly. And even if I go to 50, 60, okay, so see, I can go up to 80. That's the generator. So it drops down a little bit, and that's like 750. So yeah, that's probably true. This generator probably is an 80 meg generator. But let's go back down to here. And I'll go from 30, 40, 50, 60, 70. Wow, and that's kind of amazing. It actually almost looks better at 70. And then there's 80. So it's amazing that it actually captures that signal. Now look, this says 20 megahertz. So this tops out at 20. Now there's 29, 38, which it's 60. So there's 50, but now, so it'll read up to 50 megahertz. So, and if I hold this, so you know what? Let's capture more band, because it almost looks like it's just modulating, right? Yeah, see how like sometimes it's not there, sometimes it is? So if we come out here, and what we could do is go to single capture, and then it would capture the wave. But I can put the trigger up too, a little bit higher. Whoops. Let's make the waveform a little bit higher. Okay. And then I can go to trigger and move the trigger up so it's only capturing the peaks, right there. And then when it captures it, I could capture it. But you know, I mean, this is funny because you wouldn't be thinking of doing this if you didn't know if it was a real sine wave, but it does kind of capture. It's 50 meg, 1.4 volts, and it's putting out 3 volts peak to peak. So yeah, that's actually pretty close, but there's just not enough samples. I don't think they put enough samples in this to get a good capture at 50 megahertz. Now, if we go up to the 01, you can see it's just fine. Now, it's kind of interesting. I'm at 50 megahertz, and actually when I come over here, it says 50 megahertz. So it's actually, you know, actually almost doing as well as the 703, and it's showing 1 volt. Well, 0.7 volts RMS, so actually that's not bad. I just thought I'd give you a close-up of the Zotek since we're using it for this test. I did a review before. I'll put the link down below. All right, guys, so what do you think? Now, remember, this was an early version. They let me know that. They asked me if I was okay with checking out an early version. I think they wanted feedback. They asked for that. So you got to really hand it to them for, you know, doing that, helping, you know, get people out there like us to look at things and give them some feedback and help. And, you know, there's bugs that they could find for sure, but there's other features that, you know, that they may not have thought of. So it's really nice that they did that. I really appreciate it. 2 thumbs up to Zotek for sending this out. Appreciate that. It was fun to play with it. This video was long and took a lot of time, a lot of effort. Had to redo things. Had to tear down my bench. I tried to show you the 01, the Zotek, just to give you guys some different things to look at. Plus, the Zotek's the fastest generator I have. So, yeah, and the 01, you know, really nice scope. So, I just want to show those things every so often. And it's a bench-made scope. It's far more expensive than these, but but that's what you get. I mean, for the price, these guys are, now we don't know what this price is yet, I don't think. Now this one, I mean, the price is really reasonable for what you're getting for these kind of meters. I think they're really reasonable, and they're really helpful. I mean, you can almost set up a full bench with one of these guys, right? Hopefully that generator comes a little further along, and really curious what the app menus are going to do. Hey, I want to give 2 thumbs up for the, I think I had 1 person hit that super thank you button in the last couple weeks, so really appreciate that, guys. Buy me a cup of coffee, buy me a beer. Really appreciate that. Weekend's coming. think I'm going to buy me a beer after this video. Wow. Yeah, this is a tough one. Give me a like. Just like for effort, if nothing else, because, yeah, this is a tough video to do. These long ones are a real pain. It's like a logarithmic function. The longer the video is, it's like, it's not a linear thing. It's, you know, a long video like this takes me, I could have done 5 or 6 videos, but I wanted to do this because I wanted to really fully vet out this and give you guys a good look at it. Because I've watched several videos and I'm like, yeah, I didn't really see this, didn't really see that. So let me know what you guys think of that, okay? 2 thumbs up my Patreon. You can become a patron for as little as $1 a month. Links down below. And, oh, 2 thumbs up my members of my channel. Really appreciate that. And I got a couple new Patreons. That's awesome. Yeah, that's been really slow growth. So really appreciate that because even though I get some freebies, put out a lot of money on buying things. So thanks guys, really appreciate you guys watching the video. Give a free support to the channel by liking the video, sharing it, that kind of thing. And let me know what you guys think of this, okay? I'm not sure if I want to do another long video like this. So what do you guys think? Was it valuable? Was it too long? Let me know. Appreciate your comments, and we'll see you next time.